Hello friends, welcome back to our channel. Proceeding further in vectors, we are going to solve a few set of problems. Now, let's start with the first one. Here, in this question, we are given that if 3 times mod of A vector is equal to 2 times mod of B vector is equal to mod of A vector plus B vector, then we are required to find the angle between A vector and B vector. So, let's start with the solution. Let us suppose the angle between the two vectors is theta. That is, suppose this is suppose A vector and this is suppose B vector. Let this be theta. Now let's start the solution. Now we know that mod of A vector is basically 23 upon 4 3 is 12. Now here you can see that the value of cos theta is 23 by 12, which is basically greater than 1. Now we know that this is not possible because the range of cos theta is, the range belongs to -1 to 1. But here we are getting a value which is greater than 1. So this situation is not possible. In other words, no such values of A and B exist. So we can write no solution for this question. Therefore, no solution. Our next question is, we are given this diagram. This is A vector, this is B vector. This is the theta is basically the angle between A vector and B vector, and C vector is the resultant of A vector and B vector, which is making an angle alpha with the vector A vector. Now, in the first question, we have to find the relation between A vector, B vector and C vector. So we can see from the triangle law of addition here, A vector plus B vector is basically C vector. So we can write the first solution as A vector plus B vector is basically C vector. We can see this by triangle law of addition of vectors, because C is basically the resultant of A vector and B vector. Now, in this question, the question number 2, we are given that the magnitude of A vector is 2, the magnitude of B vector is 3, and the angle that the resultant C vector is making with A vector is basically alpha, which is basically 45 degree. So now, using these conditions, we are to find the angle between A vector and B vector, which is basically theta. Now we can use the direct formula, which is tan alpha is equal to B sin theta upon A plus B cos theta. I hope all of you have remembered this formula. Now putting the values that we are given, tan alpha, which is alpha is basically 45 degrees, so tan 45 is 1. B, which is 3 sin theta upon A, which is 2 plus B cos theta, 3 cos theta. Now rearranging these terms, we are getting 2 plus 3 cos theta is equal to 3 sin theta. Next, we have to square both the sides, so that either we can substitute cos square theta is equal to 1 minus sin square theta, or sin square theta is equal to 1 minus cos square theta. From here, we are writing, squaring both sides, we are getting left hand side 4 plus 9 cos square theta plus 12, 3 multiplied with 2, 6 to the 12 cos theta, which is equal to 9 sin square theta, and in place of sin square theta we can write 1 minus cos square theta. Now rearranging, we are getting 9 cos square theta plus 9 cos square theta, which is 18 cos square theta plus 12 cos theta, and 4 minus 9, which is minus 5, is equal to 0. Now let cos theta is equal to t. Then it becomes 18t square plus 12t minus 5 is equal to 0. Now this is a quadratic equation. I hope using the formula, direct formula, x is equal to minus b plus minus root under b square minus 4ac upon twice a, you can calculate the value of t, which will be the value of cos theta, and by taking the cos right hand side we will get theta is equal to cos inverse of a number. Next we are going to see an important operation. Suppose we have an expression of type a cos theta plus b sin theta. Suppose we have this expression a cos theta plus b sin theta, and we have to handle this expression. Then we can write it as a upon root under a square plus b square cos theta plus b upon root under a square plus b square multiplied with root under a square plus b square. Now if this is a and this is b, then this side is root under a square plus b square. Suppose this angle is alpha, then here we can see here sin alpha is a upon root under a square plus b square. So we can write it as sin alpha cos theta plus, this is basically cos of alpha. Here we have missed an expression, that is I am writing here sin theta multiplied with root under a square plus b square. Now here you can see we are getting root under a square plus b square sin of theta plus alpha, where sin alpha is this value and cos alpha is this value. We are writing it here. Sin alpha is equal to a upon root under a square plus b square. Cos alpha is equal to b upon root under a square plus b square. This is an important derivation because when we get to see such type of expression, we can directly convert it into this form, and it will be helpful in solving the problem further with some easy steps. Next we are going to solve a problem. Here we are getting that this is a vector, b vector and c vector. The angle between a vector and c vector is alpha, and this angle is 90 degree, and the magnitude of a vector is 8 units. And here we are given another diagram. This is d vector, c vector and e vector. E vector is making an angle of 30 degree with this vertical line, and this vertical angle makes 90 degree with this line, that is d vector. And the magnitude of d vector is 12 units, and this is the same angle as alpha. This is c vector, this is also c vector. Now we are required to find the angle alpha. That means we are required to find the angle alpha, that is the angle between a vector and c vector, and also the magnitude of c vector. These are the two questions asked in this single question. So let's draw another figure of this diagram. Let the magnitude of c vector be x. This length is 8, and this is B, and this is alpha, and this is 90 degree. And let's draw it once again. Let's draw a perpendicular from this point to the line D vector. Then this will be 8, and talking about this portion, this is 8 because it represents the same thing. This is x, this is also x, this is alpha, and it is 8, so this is 8. So this length is going to be 4 units because as a whole it is 12 units. And this is E. Let's suppose its magnitude be E, and since this angle is 30 degree, therefore this angle must be 60 degree because this line is vertical to this line. So this angle is also 30 degree. Let us suppose this altitude's length be y. Then from this diagram we can write cos alpha. Cos alpha is basically 8 upon x. So we can write x cos alpha is equal to 8. This is the first equation we are getting. And from this diagram we can write cos alpha is y 8 upon x. No, from this diagram we can write sin alpha is equal to y upon x. So x sin alpha is equal to y. This is second equation. And from this triangle, right angle triangle, we can write tan 60 is equal to y upon 4. Tan 60 is equal to y upon 4. Simplifying this equation, we are getting y is equal to tan 60 is root 3, so 4 root 3. This is equation third. From equation 2 and equation third, we are getting x sin alpha is equal to 4 root 3. X sin alpha is equal to 4 root 3. This is equation 4. Now, squaring and adding these two equations, we are getting x square cos square alpha plus x square sin square alpha, and taking both x square common, we are getting x square multiplied with cos square alpha plus sin square alpha is equal to 64 plus 4 16 3 the 48. The value of this expression is, as we all know, 1. So we can write, let me have the board, x square is equal to plus 4 12 2 6 4 10 11. So the value of x, since x represents the magnitude of a vector, it is either positive or 0. It can never be negative. So we can write, we can ignore the negative sign and we can write x is equal to root under 1 1 2 unit, which is basically mod of C vector. Now we can also find the angle alpha from the diagram. Let's draw the diagram once again. This is x, this is alpha, and this is 8, this is b. This is basically the magnitude of a vector we are writing. Now from now we know the value of x, so we can write down the value of alpha as you know, x cos alpha is equal to 8. So we can write cos alpha is equal to 8 upon x, which is basically 8 upon root under 1 1 2 and we know that this value lies between -1 and 1. So this expression is valid, therefore alpha is cos inverse of this term. Solved. Now we should know that the angle between two vectors must lie between 0 degree and 180 degree, and it can also be 0 or 180 degree. So we can write one important note, that is the angle between two vectors, which is represented as theta, belongs to 0 to 180 degree with closed brackets. 0 degree occurs when both the vectors are pointing in the same direction, and 180 degree occurs when both the vectors are pointing in opposite directions. Next we are going to see the parallelogram law of vector addition. Parallelogram law of vector addition. In the triangle law of vector addition, we use the head-tail combination. Now in this parallelogram law of vector addition, we are going to use the tail-tail combining condition. That means suppose we are given a vector this and we are given another vector this, v vector, and we are required to find the resultant vector using these two vectors. That means we are required to find r vector, which is basically a vector plus b vector, using the parallelogram law of vector addition. Now we have to put the tails such that both the tails of the two vectors coincide at the same point by parallel shifting. This is a vector. Now in this law of vector addition, we are going to assume the two vectors as two adjacent sides of a parallelogram, and by assuming this concept, we are going to reconstruct this diagram as a full parallelogram. Now we have constructed the parallelogram. Now this diagonal vector whose tail coincides with the tails of the two vectors a vector and b vector is the resultant of this two vectors a vector and b vector. And this is the parallelogram law of addition. Here we can see another diagram. Suppose this is c vector and this is d vector. Suppose we are required to find the resultant of these two vectors, then we have to reconstruct this parallelogram. Let's construct this parallelogram. Then this vector is going to be the resultant of these two vectors, c vector and d vector.